Alrighty, so for this video, we're going to go over section 1 of exam 4 in relation to antiderivatives. Specifically, we're going to go over parts B and D. So for part B, we're asked to find the integral of cosine x minus cosecant x cotangent x minus 1 over 1 plus x squared plus pi dx. And in part D, we're asked to find the integral of e to the power square root of x over square root of x dx. So starting with part B, when it comes to antiderivatives, you are just basically undoing the derivative that we have here. So in this case, this cosine x represents the aftermath of a derivative rather than just like taking or finding the derivative of cosine x. So we got to think in terms of what trig function gives the derivative cosine x, which in just this case would just be sine x. So if we just were to write that right here, we want to start off with sine x, which represents the antiderivative of cosine x. And keep in mind that we want to do this term by term, so we want to take the antiderivative of this. So we want to do it step by step accordingly. So what is the antiderivative of cosecant x cotangent x? That should just be cosecant x, because the derivative of cosecant x results in negative cosecant x cotangent x. And then when it comes to negative 1 over 1 plus x squared, that is just the antiderivative of that is just tan inverse, because tan inverse, the derivative of tan inverse results in this term right here. So in this case, would just be tan inverse of x. And then finally, we have pi. So undoing the derivative of pi, what gives the derivative of pi? So in this case, it would just be pi x, because the derivative of pi x results in pi. So as I mentioned before, you are just undoing the derivative that you have in this expression. So this final evaluation should be the answer. And then for part B, or D, I should say, sorry, as I mentioned in the last video, what we want to do is we want to utilize u sub and substitute it with the inside function. So in this case, the inside function can be represented by root x. So we can just say u equals root x dx. And then now we want to find the derivative. So the derivative of du equals 1 over 2 root x dx. And then dx should just result in 2 root x du, because you're multiplying both sides by 2 root of x in order to get rid of 2 root x on this side and just finally have it on the side of the du. So now that we have this information right here, we can start assembling our evaluation. So we want to rewrite this in terms of u. So we have the integral of e to the power u, because root x is the inside function, over root x dx. But now, since we already have dx, we could just scratch that and just say that dx equals 2 root x du. And now we can just work this algebraically. So we want to cancel the root x's right here. So we would just end up with the integral of e to the u times 2 du, which is gives you the integral of 2e to the u right over here. And then the integral of 2e to the u just equals to 2e to the u plus c. You want to make sure, I forgot earlier to mention, but when you're finding the antiderivatives, you want to make sure that you add plus c, because c represents the constant when it comes to antiderivatives. So when you're taking the derivative of a constant, it's always going to be 0. So if you're undoing the derivative, you are going to have that constant back. But because we don't have the specific constant known at all times, we just use c as a variable to represent it. So if I could just like correct this a little bit over here as well too, and make sure that I have included as well too, you want to make sure you do not forget the plus c. as it can be easily forgotten, as I have here in this instance. So moving on, now that I have the final expression right here, I want to substitute u into this in order to have the full expression complete. So in this case, substituting it in, this would just result in 2e to the power root x plus c. This would be the final answer in this case.